Hi, good morning, my dear students. I'm Daphne Khor. Welcome to my channel. Spark Brilliant, Inspire Life. In our daily life, if we have 2 items, we call it a pair. 6 items, a half dozen. If we have 12 items, we call it a dozen. Now, think about atoms. There are too many atoms inside. We cannot count them one by one. So, the counting unit depends on what you are counting. For example, we use dozen for eggs, pair for a pair of shoes. What about atom, molecule, or ions? We use mole. Mole is the unit of the amount of a substance. The symbol is MOL. You see, when we say a dozen, it means 12. In the same way, when we say 1 mole, it means 6.02 times 10 to the power of 23 particles. This number has a special name. We call it Avogadro constant or Avogadro number. So, the mole concept is the basic concept in chemistry. Just like in English, we start with letters. In chemistry, we start with mole. In this video, I will show you how to connect the mole concept with the chemical equations. So, you need to know how to write the balance equation first. I will use some past year questions. Now, let's look at the formula related to the mole.
In SPM Chemistry, many students think that the mole concept is just one topic, but actually the mole concept appears in almost every topic. Some of the past year questions ask directly about mole. For example, number of moles, number of particles, volume of gas, mass of reactants or products. But many questions do not mention the word mole at all. However, when you start solving the questions, you will realize that you must use the mole concept to answer it. You cannot avoid the mole. Even if the question look like redox, chemical reactions, empirical or molecular formula or gas calculations, everything still goes back to mole. That is why I always tell my students the mole concept is not a chapter, it is a tool. It is the language of chemistry. If your mole concept is weak, many questions will look difficult. But if your mole concept is strong, the questions become structured and manageable. Since the basic concept in chemistry is the mole, that is why I have summarized all the mole formula in this diagram. As I always tell my students, everything in chemistry must go through the mole. You only need to remember this idea. If you understand this diagram well, you can answer almost all mole-related questions in SPM. In the center of the diagram, we have the mole. The mole acts as a bridge that connects particles, mass, volume, and concentrations. No matter what information the questions give you, mass, volume, particle, or concentrations, everything must first be converted into mole. Using the summary of mole diagram, let's look at some past year questions examples. For example 1, here is the information given. The mass of X is 3.2 grams and it asks for reactive molecular mass. Firstly, convert the volume cm cube into correct unit, which is dm cube. From the summary diagram, we can see that these questions involve mass and gas volume. Since everything in chemistry goes through the mole, we will use these 2 formulas to find the number of mole first. That is why everything goes back to mole. At first, to calculate the number of mole of the gas, we know that 1 mole of gas occupied 22.4 dm cube at STP, so we can use this relationship to determine the number of mole. Then use the mole formula to calculate the reactive molecular mass of the gas S.
From the given informations, we have Avogadro number and molar mass. Then we need to look for the number of nitrogen atoms in the compound by using the summary mole diagram. The information from the questions involve mass and number of atoms. So, we need to use these 2 formulas. Use the mass mole formula to determine the number of mole of the compound. Be careful here. The 0.5 mole refers to the number of moles of NH4 and O3 compound here, not the nitrogen atoms. However, the questions ask number of nitrogen atoms, so let's look at how many nitrogen atoms are present in NH4 and O3. In one formula unit of NH4 and O3, there are 2 nitrogen atoms. Therefore, there are total 2 nitrogen atoms per formula unit. Finally, from the summary mole diagram, 1 mole is equal to 6.02 times 10 to the power of 23 particles. Therefore, the number of nitrogen atoms in the compound is equal to 1 times the Avogadro number, which means the final answer is equal to A.
The given information from the question is 2 mole of iron 3 nitrate. We need to find out the number of nitrate ions. From the summary mole diagram, we can see that these questions only involve mass and number of particles. So we will refer to these two parts of the mole formula. At first, we need to determine the number of mole of nitrate ion in iron 3 nitrate. This is the formula for iron 3 nitrate. The dissociations of iron 3 nitrate in water break into its constituent ions, forming one aqueous Fe3+ and 3 aqueous nitrate ion NO3-. This means one formula unit of iron 3 chloride contains 3 nitrate ions. From the questions, we need to determine how many nitrate ions produced if there are 2 mole of iron 3 nitrate. By using mole ratio, 1 mole of iron 3 nitrate will produce 3 mole of nitrate ions. Therefore, we will determine 6 mole of nitrate ion in 2 mole iron 3 nitrate. Use Avogadro constant. 1 mole is equal to 6.02 times 10 to the power of 23. So from the mole ratio, 2 mole of iron nitrate contains 6 mole of nitrate ions. Therefore, the number of nitrate ions is 6 times the Avogadro numbers. In the next example, I will show you how to link the summary mole diagram with the chemical equations. Of course, the first step is that you must know how to write a balanced chemical equations. Remember, everything starts with a balanced equations. Without it, the answer will be wrong. From the questions, we are asked to determine the volume of nitrogen dioxide gas when 18.9 gram of zinc nitrate is heated. The information given involve mass and volume. So from the summary mole diagram, we can see these questions only involve mass and gas volume. So we will refer to these two parts of the mole formula. Now, the question only gives the mass of the reactant, so how do we find the volume of nitrogen dioxide gas? We must use the balanced chemical equations to determine the mole ratio. The coefficient in a chemical equation represents moles, not grams, so we cannot use mass directly to do the ratio. We must convert the given mass of zinc nitrate into moles. After we know the number of mole of zinc nitrate, only then we can use the mole ratio from the balanced equations to find the number of mole of nitrogen dioxide produced. According to the balanced equations, 2 mole of zinc nitrate produce 4 mole of nitrogen dioxide gas. So, we need to convert mass to mole first. To do this, we use the formula. 18.9 gram of zinc nitrate is equal to 0.1 mole. Then use mole ratio from the chemical equations. 2 mole of zinc nitrate will produce 4 mole of nitrogen dioxide. Therefore, 0.1 mole of zinc nitrate will produce 0.2 mole of nitrogen dioxide gas. At STP, 1 mole of gas occupies 22.4 dm³. Since we have 0.2 mole of nitrogen dioxide gas, therefore the volume of nitrogen dioxide gas released is equal to 4.48 dm³. The questions only give the mass of iron 3 oxide, which is 16 gram, and the relative atomic masses of the atoms. Without any other informations, the question asks for the mass of magnesium needed to complete the reactions. There is no other numerical informations. At first, students may feel confused. There is so little information. How can I find the mass of magnesium? This is because they forget that they already have two powerful tools: the summary mole diagram, the balanced chemical equations. By using the given information together with these two concepts, we can solve the questions correctly. From the summary mole diagram, we know that mass, volume, and concentrations must all go through mole. These questions involve only mass and mole. So, we only need to use the mass mole formula and the mole ratio from the chemical equations. I always advise my students to write all the given information below the chemical equations. This helps you to see clearly what is given and what is required. First, calculate the relative molecular mass of iron 3 oxide. And then calculate the number of mole of iron 3 oxide is used. From the mole ratio of the balanced equation show that 1 mole of iron 3 oxide reacts with 3 mole of magnesium. So we have 0.1 mole of iron 3 oxide here. Lastly, we will get 0.3 mole of magnesium needed. After we determine 0.3 mole of magnesium, then by using the formula, convert the moles of the magnesium into mass. So the answer is 7.2 gram. Now, you can see something very important. Even when the question gives very little information, we can still find the answer by using the mole concept correctly. That is why the mole concept is the most fundamental concept in chemistry. Always remember the summary mole diagram, the qualitative and quantitative information in a balanced chemical equations. When you understand these two, chemistry questions become possible, calculations become systematic, and problem solving becomes logical.